Welcome to Spring LIB.
So here in this problem we are given that the mass of the space tuck, let it be mt, we have given as 3300 kg, 3300 kg. Now the mass of asteroid we are given as 6650 kg, and they pull on the asteroid with a force of 674 Newton. That means the force acting on each of these two bodies we are given as 674 Newton. Now the initial distance between their position D we are given as 409 meter. Now we have to calculate that how much time does it take for the ship and the asteroid to meet. Basically, when they are moving, it would be moving in this direction and this would be moving in this direction. So they are asking at what time they are going to meet. This is what they are asking in the question. Now first of all, we'll be calculating this distance. Let this distance be x1 and let distance traveled by asteroid be x2. We'll be calculating this distance x1 and x2. For that, we have to calculate the acceleration of the space tuck and the acceleration of the asteroid. So the acceleration of space tuck would be equals to F over m. We have just used the Newton's second law of motion, that is sigma F net would be equals to mass into acceleration. From here we can write this thing. So force acting is 674 Newton divided by mass of, we will take the mass for space tuck, which is 3300 kg. So from here, acceleration of space tuck comes out to be as 0.2042 meter per second square. Similarly, we'll be calculating the acceleration of asteroid. So it would be equals to m over ma. Force we have same, that is 674 Newton. Now mass is 6650 kg. So from here, acceleration of asteroid comes out to be as 0.1035 meter per second square. Now from here we can calculate the distance traveled by the space tuck and asteroid. So we'll be calculating x1 first. For that we'll be using the equations of motion. So x1 will be equals to ut plus half at square. And the data we have to take it for space tuck. Now initial velocity of the space tuck was 0. So this term would be 0. So we are left with this one. So plus 1 over 2. Now acceleration of space tuck we have this much. So we can plug it here. 0.2042 times t square. Similarly, we can calculate x2. That is the distance traveled by asteroid. We'll be using the same equation, ut plus half at square. This time we have to take the data for the asteroid. So it would be equals to, here also its initial velocity was 0, so this term would be 0. Now we can put other values. So 1 by 2. Acceleration of asteroid we have this much, so 0.1035 times t square. Now this distance x1 plus x2 would be equals to this distance d, which we are given as 409 meter. Now we can put x1 and x2 here to calculate this time t. So x1 we have this much. So 1 over 2 of this number would become 0.1021 t square, plus here it will become 0.05067 t square is equals to 409 meter. So from here the time t would be equals to 409 divided by this value 0.1021 plus 0.05067 and root. So from here time comes out to be as nearly 51.74 second. So finally we can conclude that the time taken by the ship and the asteroid to meet is 51.74 74 second. So I hope you have understood the problem. Thank you.